additional problems on the application of the Archimedes principle on buoyancy. So let's read the problem. A concrete anchor, specific gravity is 2.4, weighs 670 newtons, tied to the end of the long timber. Ito yung dimension niya, 6 meters ang haba. The anchor does not reach the bottom of the container, but submerges 5 meters of the timber. So ano yung specific gravity ng timber? Bakit hindi siya lumubog? Huli. Okay? Then, kung hindi siya lumubog, ano pa yung dapat na idagdag na pabigat para siya ay to submerge completely. Okay? So let's solve. Okay? So ito yung problem. Ito yung timber natin. Okay? Ang haba, ang taas niya. The length of the timber is 6 meters. Ito yung kanyang cross-section, 0.2 by 0.2. So, ito yung water ito, tubig yan. So, inilibog sa tubig, in the container, pero may pabigat. So, may pabigat, this is the anchor. Okay, ang weight ng anchor is 0.67 kilonewtons, pero hindi lumubog. Okay, with this weight of the anchor, pabigat, ang lumubog lang po sa 6 meters is 5 meters. So, ang tanong dyan is, anong specific gravity ng timber nito? Mukha na yan. So, sabi ganon, the weight of the fluid displaced is the buoyant force. So, yung part na ito, yung 5 metro na ito na lumubog, ay acted upon by a buoyant force, BF1. Okay? Kasi, yung lumubog yan, it displaces this volume. Yung volume na yun. Tapos, ito yung pabigat, may volume din yan, so it displaces the same amount of volume na kasing laki ng volume ng anchor. And that is BF2, the buoyant force acting on the anchor. So if we apply the principle of mechanics that summation of forces vertical is equal to 0, yung buoyant force acting on the anchor, BF2, plus the buoyant force acting on the timber is equal to the weight of the timber and the weight of the anchor. So ayun yung equation natin. How do we solve for BF1? That is the weight of the fluid that is displaced. Ano ba yung displace nito ang timber na ito? So, yung volume na yun. Tubig, yung displace niya sa tubig, tsaka yung volume na displace ng lumubog na timber. So, yun yun. Yung BF2, okay, ano ba yung displace niya? Tubig din. Ano yung volume nun? Okay? Yun ang volume ng anchor. And how do we get the volume of the anchor? So, we know that the weight of the anchor is 0.67, the unit weight of the anchor, concrete siya, is 2.4 times 9.81. So, ito yung volume ng pabigat, ng concrete na pabigat. So, we solve for BF2. Ayun. Ayun siya. So, ayun, BF2. The weight of the timber, okay, is the unit weight of timber times the volume of timber. So, yung timber natin is 0.2 by 0.2 times its length, volume yun. Ayun siya. So, it's in terms of the unit weight. And then, so meron na tayong lahat. Substitute natin dito lahat. Okay, BF1, 1.962. BF2 is 0.275. Then, the weight of the timber is 0.24. And the weight of the anchor is 0.67. So, ito ngayon yung weight ng timber. So, ito lang yung unknown. The weight of the timber is 6.529 kilonewton. Unit weight per volume. So, since we know that the unit weight of any quantity divided by the unit weight of a standard substance, which is water, gives you the specific gravity. So, the specific gravity of timber is 6.529 over 9.81. That is 0.66. Kaya hindi lumubog yung timber kasi less than 1 yung kanya specific gravity. Okay. So ngayon, sa pangalawang problem, kailangan dagdagan yung pabigat. So may additional weight tayo para lumubog completely yung timber. So 6 meters na yung nakalubog. So it is again acted upon by buoyant force. This anchor is also acted upon by buoyant force 2. So this is the weight of the timber. This is the weight of the anchor plus magdadagdag nga ng pabigat para completely lumubog. So again, applying this principle, yung buoyant force acting on the timber, saka yung buoyant force acting on the anchor, ay equal to sa weight ng timber, saka sa weight ng anchor. Okay? Ito yung weight ng anchor na. Ang dati, tsaka dinagdagan. Okay? So, what is BF1 now? The volume of the fluid displaced. So, ang volume na nito, yung volume na ng 0.2 by 0.2 na 6 liters. Okay? So, 2.35 na yung buoyant force acting on the timber. BF2. At ito na ngayon ay the unit weight of the fluid that is displaced, tubig, ano yung volume niya. Ang volume ng una, which is 0.028, dadagdagan pa ng additional volume. Okay, so ayun yun. Then, the weight of the timber, okay, alam na natin yun. Okay, 1.554. Kasi alam na natin yung specific gravity niya. Weight of the anchor is 0.67, even siya. So, ano na yung additional? What is the additional weight? So, this is the specific gravity of concrete times the volume additional. So, in terms of the additional volume, ito na yung dadagdag na volume ng concrete anchor. Doon sa 0.028, ito yung dadagdag natin. Okay? So, ang volume additional concrete, the weight. Okay? So, alam na natin volume na idadagdag. Gano'n siya kabigat. So, we are going to add 0.68 kN to submerge completely. Okay. So, continuing our discussion of the Archimedes principle, let us read the problem. A wooden barge is 16 meters long, 7 meters wide, and 1.3 meters deep. This measurement is the measurement of the outside dimensions of the barge. Then, the sides and bottom of the barge has uniform thickness of 0.3 meters. If the barge has to maintain a freeboard of 30 centimeters in seawater, seawater is heavier than fresh water, kaya ang specific gravity niya is 1.03. How many cubic meters of sand, whose specific gravity is 1.6, can be uniformly loaded into the barge? So, we are going to use the specific weight of timber as 7,860 Newton per cubic meter. Okay, so this is what the problem states. Okay, so meron tayong barge. Okay, the sides, the bottom of the barge ay may thickness. Ito ay made of timber. Ano? This timber is 0.3 uniform thickness. Okay, then kakargahan siya ng sand. So, ilang volume ng sand ang pwedeng ikarga so that it will not be submerged. Okay. So, ito yung figure. So, applying the principle of Archimedes, okay, that the any body that is submerged in a fluid at rest will be acted upon by a vertical resultant force, which we call the buoyant force, equivalent to the volume of the fluid that is displaced by the submerged body. So, applying the principle of equilibrium, that all the summation of forces vertical must be zero, what are the vertical forces acting on the barge? So, it is the weight of the barge itself, okay, and the weight of the sand that will be loaded in the barge. So, it is acted upon by a vertical upward force, which you call the buoyant force. So, applying this principle of equilibrium, the buoyant force is equal to the weight of the sand plus the weight of the timber. So, how do we solve for the buoyant force? Okay, the buoyant force, sabi ni Archimedes, is the weight of the fluid that is displaced by the object. So, ano ba yung fluid na dinisplaced ng barge? Seawater. What is the volume that was displaced? So, yung volume ng barge. Okay, the volume of the barge is, so allowing a freeboard of 3 meter or 30 centimeters, yung volume ng barge na nakalubog ay 1/7 by the length of 16. So, the buoyant force acting on the barge is 1,131.68 kilonewtons. Okay. Now, the weight of the timber, okay, the weight of the timber is equal to the unit weight of the timber multiplied by the volume, the total volume of the timber making up the barge. So, ano yung volume ng timber na yan? Okay, ito, okay. So, ang volume ng timber ay yung area nitong lahat na ito, pati yung dalawang sides sa harap tsaka sa hulihan. So, yung volume na total, minus mo yung maliit na ito, so that will be the volume of the timber. So, this is 7 by 1.3, okay? 7 ito, this is 1.3. okay, times the length of 16, ibawas natin itong maliit na rectangle na to, 6.4 by 1 by 6 by 15.4. Okay, 15.4. So that's the total volume of timber. So multiplying that by the given unit weight of timber, which is 7.86 kilonewton per cubic meter, the weight of the timber that makes up the boards is 369.73 kilonewton. So meron na tayong lahat. Buoyant force, weight of timber. So ang atin na lang kailangan dun sa equation 1, from this equation 1, is the weight of the sun. Okay? So, what is the weight of the sun? That is 761.95. But we are asked to determine ilang cubic meter ang pwede ikarga dun sa boards. So, if the weight of the sun is 761.95, that is equal to the unit weight of sun multiplied by the volume of sun. So, we have the weight of the sun, 761.95. What is the unit weight of sun? Given sa ating problem, the specific gravity of sun is 1.6 times 9.81. The volume of sand na pwede mong ikarga dun sa boards is 48.54 cubic meters without sinking. Another application for our Archimedes principle. Let's read again the problem. A balloon has a solid weight of 3,560 newtons that contains gas with a volume of 4.25 cubic meter. The specific weight of that gas is 3.5 newton per cubic meter. Ilang newtons of ballast is necessary to hold the balloon on the ground if air weighs 12 newton per cubic meter. Okay, so this is a balloon. Meron lang yung balloon ay gas na ang specific weight is 3.5 newton per cubic meter. Air is 12 newton per cubic meter, so mas lighter itong gas na nando sa balloon. So ang tendency for the balloon is lilipad-lipad siya. Okay, lilipad-lipad siya. So kailangan ng pabigat. Okay, ilang newtons of this ballast will be required to hold the balloon on the ground para hindi siya lumilipad-lipad. Okay? So, okay, yung volume ng gas na nandun sa loob ng balloon, yun din ang volume ng balloon. So, that is common sense. Okay? So, again, what are the forces? Okay, sulat natin yung mga forces acting on the balloon. Okay, so it is acted upon by buoyant force. We are now talking of air. Okay, we are not talking of any fluid or water or anything but air. So the buoyant force, okay, is equal to the volume of the air displaced by the balloon. So that is equal to ano yung mga forces again? Yung weight ng gas na nandun sa loob ng balloon, yung weight ng balloon mismo, tsaka yung idadagdag na pabigat para yung balloon ay hindi lilipad-lipad. Okay? So, again, applying the principle of mechanics, okay? Summation of all forces vertical is equal to, sa lahat ng weights na yan are downward, being pulled by gravity. So, ang buoyant force is equal to the weight of the balloon plus the weight of the gas plus the weight of the ballast. So, ito yung ating equation. Now, what is the buoyant force? Okay, the unit weight of air is given as 12 newton per cubic meter. Yung volume ng air, yun yung volume ng gas. That is equal to 425 cubic meter. So, ayun. Ito yung buoyant force acting on this balloon. Okay, we use the air kasi air lang surrounded by air. Now, the weight of the gas is the unit weight of gas times the volume of gas. So, given yung unit weight ng gas na 3.5 newton per cubic meter. Then, lighter than air, which is 12 newton per cubic meter. So, ang weight ng gas na nando sa loob ng balloon is 1,487.5. The weight of the balloon itself is 3,560 newtons given on the problem. Okay? So, i-substitute natin lahat. Okay? Ang wala na lang tayo is the weight of the ballast. So, ito ang kailangan pa. Okay? We need 52.5 newtons of weight of the ballast para itong balloon na ito ay magstay on the ground. Okay?